Okay, got Brianna and myself, Mitzi, on our call today. We're gonna just kind of go over our review our homework quickly before we start our quiz. Um, okay, so number one of two conditions must be satisfied in order for the distribution sample means to be normally distributed. And the two conditions were in the homework problem. Did you see that?
No. All right, so are we on lesson 6 homework? Is that what you're still doing?
Oh,
Or
lesson 7,
lesson 7 homework or the preparation?
preparation.
Okay, sorry. I'm just,
Okay.
let me open this other one. Okay, what are the two conditions?
Yeah. So it's a
Well,
parent pop.
you,
Go ahead.
yeah. No, that's just what I was gonna say. Because in like the last chapter we read, if the parent population is normally distributed, then the next one would be 2.
Right. And then B would be this the central limit theorem guarantees that the distribution of X is normal if the sample size is large. And I think
Yeah.
for the most part, I'm still trying to
Yeah.
understand it because I thought it was larger than 30, but in some cases it could be less than 30, but it's still large.
Oh, well, that's
So
really weird because it is larger than 17. I thought too.
yeah, yeah, I was trying to figure out the exact answer for that.
Yeah.
Um, oh, is that Mariella?
Yes.
Hello, Mariella. How did you do on the homework?
Yeah, fine. But the second part,
Uh-huh.
I think was, I have some questions. Number
Okay.
10 and 11, but after. Don't worry.
We're just reviewing the homework right now. We're just kind of going through it quickly. I think do we all understand number 2, the value, what this formula for the z-score is?
Yeah.
Yeah.
Yeah. And then number 3, the a the probability
Yeah, just, yeah,
and
I get
yeah,
it.
yeah. The 40th percentile for the population. I forgot to. I did that a little bit wrong. I
The
gotta.
percentage of this population. Yeah, I was remembering that just also. But in the applet, you put 40, no?
Mhm. Mhm.
Point 4. And you get the CT
Mhm.
score and you make the calculation.
Right. Which was the percentile for that for you was. See, I got negative 0.253,
Yeah. Negative.
but the answer key says something different.
No, but you have to rest. You have to rest the negative. You
Okay.
have, because of the CT score is
Uh huh.
0.253, but it's negative, yes?
Mhm. Mhm.
Yeah. But the formula is, here I got the formula to just remember. Yeah. You have to multiply that negative number with a theta that it's 5. So you got 1 point, I don't remember, 5 multiplied by this number from the theta score that it's negative, and you got less 1.265.
Okay.
And then you have to add the mean that is 10. But how is negative? So you have to rest 10 less 1.265.
That's 1.265.
And then you got 8.735.
Okay. Can you show us? I maybe I
Yeah,
because
I
I
will
have.
show my screen.
Yeah.
Let me show
Can
my
you just
screen.
switch your screen?
Yeah, this is my applet, no?
Yes.
Yeah, where you have the theta, yeah.
Mhm.
And I have my Excel. And I point here. Have to change here. Yeah, then I have the theta here.
Mhm.
And then I have to apply this formula. Here is a formula.
Oh, that's right. We solve backwards, right?
Mhm.
Negative
You have to apply this formula. And you say theta by the standard deviation that we got, that is 5, multiplying by theta, and you got this number, less 1.265. And as you see the formula, you have to solve what is x. You have to move the u to the other side, but how the number is negative, so you rest finally 10,
Mhm.
and you got the 8.
Okay. That's right. We had to solve for it. That's what I didn't do right. So with this with the standard with the mean at 10 and the standard deviation at 5,
Mhm.
you're solving for the population mean, right? So that's x minus 10 over 5. And then you
Mhm.
just run through that. Did you
Yes.
get that, Brianne?
Yeah, kind of.
Okay. So what she's showing is that we have to solve backwards. Remember in, I think, lesson 5, where we had the z-score, which was negative 0.253 already. So then we would, so the calculation would be that equals our x minus 10, which is our mean, divided by 5. And then when you
Okay.
solve for x, then you can get the population, right? Because here it says 40th percentile for this population. And so she did it in her calculator. I mean, her Excel, which came out to what again, Mariana? What was X again?
Yeah, you could see my Excel
Hmm.
here.
Yeah, your X was it went
Oh,
away.
sorry. Yeah, I took that from lesson 5, I think.
Hmm.
Yes, lesson 5.
And so you got 1.265.
1.265.
And then you put that in your applet, right?
In the applet, I put just the 40%.
Oh, I'm sorry. And then you got your Z score. Okay. 1.265. I have to like work it out in my mind, and I'm old school,
Because
so
there are many formulas, and I was have some confusions here because there is another formula you also know. We recently learned this week.
yeah.
This is this one. So you need to be careful with the words in the problems.
Okay. So just so that I can understand, Brianne, so part of the formula was so when you take the negative 0.1253
Mm-hmm.
equals x minus 10 over 5, then you bring over the 5, so you multiply 5 on both sides, and that's where you get 1.256. So 5
Yes.
times negative 253, and then you add 10 to each side, and because negative 253 plus positive 10, that's what gives you the 8.735.
Yes.
Does that make sense?
Yeah. Yeah.
Yeah. I'm still trying to figure it all out, but I'm getting there.
Okay, I wish I could see. So let me see if I can. So this is the formula. Can you see that? Right, let me circle it. So that's what you're solving for x on, right? The part I circled. Is it
Yeah.
backwards?
No, I can see it perfectly.
Okay. And then when you do the math on that, then you come up with the 8 point.
Yeah, the first time I forgot that CETA score was negative, and I get another answer. Yes, I was.
Okay.
Yeah.
Yeah.
Okay. So C, what is the z-score for an observation of 18.5? Gosh, I did this and now my brain is like fried. I can't remember how I got that. So 18.5.
1.7.
Yeah, that's the answer. I got 1.7. And I think we just did 18.5 minus the 10 over 5.
And that's it.
That's just the regular standard z-score formula.
Yeah.
Yeah. And the same is for D.
Yeah. So D, we took the yeah. But
But then you just use the other side of the applet, right?
Right. Right.
Oh,
Yeah.
Okay.
Okay, so we can kind of skip down. I think we got that. Did you guys get E pretty much?
Yes, it's the same.
Yeah, so it's the point, it's the same thing, 0.3446, but you just add them together.
Yeah.
Right, then you get the other side, 0.6892. Okay, so number 4 and number 5 are both normal, right?
Yeah, normal, yes.
And then number 6, we just had to do the math on that as well. And then plug that into the applet.
Okay.
So I know this is gonna be fun. I was I think, do you guys have any questions on any of the other ones?
No, because we got like there. Well, then we have to use in 6, 7, and 8 the CETA score. No, the formula for CETA score.
Yes.
And
6,
yeah,
7,
you have
8.
And 8. Yes.
Yeah. I did it so fast. Let me see here. Yep. The mean with the 45, the standard deviation of 10, and then it just gave you the numbers. And then you just
you have to yes, math operations.
Yeah. Did you want to take one of those? We could just do one out of the 6, 7, and 8.
I think it's okay.
Okay. I just feel like I need to practice this more, because I do it, then I forget.
Yeah, we're going to.
Yeah. No, because that one is pretty easy because it's all central, right? So, I mean, normal. So that was kind of easy. But then the right skewed ones, those are, I'm still doing the last 3 of this one. So.
Yeah, I got questions on the last 3.
Okay, so why don't we do the last 3 together? Is that okay?
Okay, yeah.
So a sample size of N4 is taken from the right skewed phone data, and you want to know the probability that the observed mean is less than 35. Can you compute this probability using normal probability applet with the information you have? Why? So the sample size is 4.
Well, you can't even use the.
Sorry. Wait a minute, please.
You can't even use the applet for that. I don't know if we're still supposed to find out any other thing, but it seems like the question's just asking, can you compute this probability? And you can't.
And why can't you, Brianne?
Because the normal probability applets for normal probability, and this one's right skewed, so it wouldn't work on it.
Gotcha. That's perfect. No, so I'm gonna write no because this is not a normal distribution, right?
Yeah, because the population is few, and you have that is skewed right, no? Right skew, no?
Yes.
For these two conditions, no?
Yes.
Yeah.
So we have that. The number 14 is the sample size of n equals 36 is taken from the right skewed phone data. What is probability that the observed mean is greater than 36.5? So 36, because we know the mean is 40. Well, so we can just factor that in, right?
Yeah, let's vote.
Oh, whoops. So multiplication 2. Okay. Okay. I think I'm lost.
I don't know. I don't got this the same answer as the.
The probability. So so is this something we plug into Applet? Because we know that our
But it's
area. Go ahead.
no, I'm just saying it's right skewed, so I don't know if we can plug it into the
Oh yeah,
output.
you're right. You're right. We cannot plug it into the applet, but
But then I don't know how to figure it out without the applet.
yeah.
And in the reading, we don't really see anything with it not being normal.
I was confused about the reading because in the reading it gave you that one problem, and then it told you to make a. Oh, there it is. Never mind. I didn't see the data collection for the thing, but that has nothing to do with this one.
I know.
Because when I was looking for the right skewed, oh, you have to get the p-value. P-value is probably a test. Huh? I want to pull my hair out.
I got a different answer from the solution because yeah, first you have to rest, no? Number 35 less 40 under the standard deviation. Just to get the zeta score and know what is the percentage, no?
So is it 35 or 36?
36?
Well, no, that's
Where-
n, right? Where do you get 35 from? Are you taking that from
Sorry.
number 13?
14. I was talking about 14.
Yeah, so 14 is sample size of 36. But what's funny is you know that these all work together, right? All these questions. Okay, you know what? I think what we could do is just kind of go to the video because let's see if he can help us understand this. Let me pull up the video because I was watching it and it's pretty good. So I'm going to share my screen. Have you guys ever seen the video at the very end? Let me kind of skip over to 14, problem 14. Okay, let me share my screen so that we can do this. Where'd he go? Have you guys seen these videos?
No.
Okay, let's watch this one. Can you hear that?
No.
You can't hear?
No.
Okay, let me bring it up. Can you hear?
Nothing.
No.
Okay, watch his screen. Okay, he's talking about number 14.
Something similar, number 14.
Yeah, he's doing 14. Watch. So he's saying that's the same formula.
They just did that formula, and the answer I got was 0.58. So we'll see what he does differently. Oh, I didn't use.
Ah, look at that.
Well,
Yeah,
I did. Oh, it's divided by 2. I was dividing by 6. That's what the equation I was using, but it wasn't. I just did simple math wrong.
Yeah, you got number 2. Zeta for you got 2 for zeta.
1.75 is really what it was, right? 36.5.
But then how do you find the...
Yeah, he's going to show us.
He's going too slow for me.
Once again, please.
What?
Divided by...
I know you could put it in there. I guess. What you doing?
Okay, so let me pause this one. So yeah, so he did use the applet then on that. So he went in and...
Yeah, but I got question. Yeah, that's what when I will show my screen. Okay.
Okay, I just I don't know what I did with my applet. I have too many screens open. All right, let me stop sharing.
Yeah. Here, you see?
Yep.
Yeah.
Well,
Wait, show
Yeah.
it again?
Right now, yes.
Okay.
Yeah. That's why my question before, because we got always with this formula, yes?
Mm-hmm.
And we have here that that we can get zeta with this formula, and it's also equal to this one with the square. Yeah. But what I don't get, I don't know how to say, very defined is where we are going to use this one with that square and when we are going to use the other one. Because
I think we use the bottom one when we have the sample size, because n is sample size. And in that last question, we saw that samples of whatever 36, so we put 36 in there. But sometimes we don't have sample size, so we just use the regular one to find z-score. Does that sound right, or?
Yeah, that's what I was going to say, because when we have the standard deviation, when we're doing it for samples, exactly the same thing. We have to calculate it using that bottom calculation, the square root. of the number.
I don't understand very well the English. So
Oh,
okay, what you're trying to tell me is that the simplest formula is for a general distribution, I think, no? With many samples. But with the square is when we have few numbers, few samples.
yes.
Well, not if it's just few, but just if you
Just a
read in the question that you have a sample size is when you use the other one.
Mhm. Not when you're doing the whole thing, right?
Yeah, when I'm choosing a part of all the population. Yes.
Mm.
Okay.
Yeah. So then we're just taking that sample size of see where it says sample size of n is 36. So when we have a small or when we have a sample size like that, then we use that formula and we plug it in to calculate the standard deviation using
Mhm.
that.
Not for all the population, just for a sample of the population.
Right.
Yeah. Okay. Yeah.
Correct.
Thank you.
So so let me go back to this question because I want to make sure I understand it. Um, so we said on 14 the answer because he stuck it into the applet, right? And he
Yeah.
got 0.99599.
190. Mhm.
Shoots. Let me see here.
And that's by just selecting the middle and the side.
Yeah. Unlike you guys, I have too many windows open.
Yeah, me too.
And I lost my applet. Hold on. I think I accidentally deleted it. Ah, shucks. Let me look. It was out of lesson 5, right?
Yeah, I don't know how I found it.
Lesson 5. Yes, lesson 5.
Yeah. Oh wait, I think I saved it.
Well, yeah.
Oh, probability. Yeah, but there we go. Okay. I just I just have to see it like you know what I get mixed up is the z score and the area. I don't always understand where to put it in, but the point negative 1.75 is actually our z score, right? The one that we figured out from this whole problem. But when I put it in and I select just the middle, I get 0.9199.
Yeah, because you select the middle and the side because it's saying what is greater than 36.5.
Oh, okay.
It'd
There
be
we go.
everything.
Thank you. That makes
Yeah.
sense. Okay, let's do this last one. See if we can do it without his help. Okay, sample size of M36 is taken from right skewed. What is the probability observed between 37.5 and 42.5?
Oh, so you would do each of them separately?
Yeah.
Okay. Oh. And your bottom would be the same.
Right.
You just divide by 2 on everything.
Yeah. Negative 1.25, right, is our z-score for the first one.
Negative 1.25?
Is that what you have? Oh,
yeah, that's what I got.
And then positive 1.25.
Yeah.
And we add that, put that in our population.
And then you put those in the Z in the applet.
And the applet.
Yeah.
I got in the applet 90
then,
maybe.
Well, then you just select the middle, right? So that should be
Well,
point.
this one, it's less than or greater than, so it's just the sides, right?
Okay.
Oh. Oh, what is there?
Oh, I guess just selecting the middle would work because you're doing the between.
The between, right?
Yeah, but in
And
the
where I can I define that is the between? Because here says there is a probability that the observed x is greater than. How can I?
So if you put in on the first one, if you put in -125 for the 37.5, then you get a probability of 0.0156. And then if you put it in positive and you just click on that, then you get the same probability, right?
yeah, but because you're looking in between them, you can just select the middle and get the answer. But the answer key is showing it's like 1 minus because it's just like subtracting the sides from 1, I guess, but either way.
Yeah. Reason.
Yeah. So you can either do that and then subtract it by 1 and or you could just select the middle too. But then because it's always going to be subtracted by 1, should give you the 0.7.
Yeah. Okay. It's okay.
Are we ready for the quiz? Oh my gosh, this makes me nervous all the time.
Yes.
Let's do this, right?
Yeah.
Okay.
Okay. All right. Let me pull up the quiz. I'm going to pull up my quiz in a different screen. So,
so many tabs.
I know.
There's not an easy week of tab pulling. Like there's so many every time.
Oh my God, 15 questions.
Okay.
It's less than it has been, so it's okay.
Yeah, we're going to take a nice breather here. So the first one's easy and the second one is easy.
Yeah.
Yeah. No, we got 2 out of 15 right.
4 points.
Okay. All right. So question 3, use a normal probability applet to find the combined area under the standard normal curve that is right of z equals 1.358 to the left of z equals negative. Okay. Round your answers to 3 decimal places.
That's okay. Just plug that in.
1.358.
You just select the outside. So I got 0.175. What?
I got 82.55.
No, because you're just doing what is left of the negative and what's right of the positive. So you just select the sides.
Ah, okay. Yeah. 17.45.
Yeah.
1.745.
Yeah, but you're supposed to just round to 3. So 0.175. Or 175.
1.75. Yeah, 0.175.
Yes.
Which of the following will have some of the standard deviation if 9 observations are randomly drawn from a population? 9. Individual observation extra sample means. Let me see here. The mean of random variable x equals sample. Have smaller standard
of 9 observations.
I don't think if 9. I don't know if we can tell or not.
I don't think so because 9 observations, but we don't know what the mean is, right?
Yeah, and
So it's just N9.
9 observations. But we read something in another lesson that if we have large samples, we have smaller deviations. Yeah, yes?
yeah, but we can't tell which one will have.
But we got few. So
We can't tell which one will have the smaller deviation because we don't know what the distribution of them are. Like, I don't think we can. But
yeah.
Yeah,
Mm.
I think you're right because we don't know
Mm-hmm.
which of the following will have smaller deviation if 9 observations. Yeah, we don't know what following, right? Because we don't know what we're looking at. We just know 9 random. So yeah, I'm gonna just go with the third one. Watch me. Well, we know that the distribution of sample means is
oh my
x squared.
gosh, this is.
I think it's a trick question.
Which of the following results implies a spread decrease in x? I don't understand the question.
Okay, so which of the following implies that the spread of the mean decreases as the sample size increases? So that is, as sample size increases and becomes large, the distribution of sample means become approximately normal. That doesn't say that it decreases. That's the central limit theorem. Large numbers is as sample size n increases, the sample mean x draws closer to the population mean. That's large number. That's a large number rule. What's the rule for the 68, 495, 4?
Is it just a normal distribution?
Well, what was the rule for the 68, 95, 97?
If it's from one standard deviation if it's one standard deviation from the mean, then it'll be 68. If it's 2, then it's 95. And if it's 3, then it's 99.7.
Okay.
Like that.
Because then we, let me look here.
I don't know.
Yeah, it could be the normal distribution rule. You're right.
Sorry, my internet went out.
Uh-oh.
So I lost.
Well, we still haven't figured out the answer to number 5.
We're number 5. I was.
Yeah. Maybe we can just keep going on the quiz and then come back to it.
What was that?
Let's just keep going and then come back to that question. Because we'll tear ourselves over it if we keep thinking about it for a minute.
I'm checking lesson 6.
Okay, number 6.
No, you're checking
number 6. Yeah, because there's what explain the central theory in the normal distribution.
Yeah, I wrote it down. Sample size increases business and becomes large. But we're saying here, the following implies that the spread in the mean decreases and sample size increases. So the mean approximately normal. I can see that happening. But it's funny because to me, the central limit theorem, I'm still trying to distinguish between that and the large number rule, the law of the large numbers. Okay. It almost seems like it might be decreases as the sample size increases. It almost seems like it might be the central limit theorem because the sample size will increase and it will, what's the word I'm looking for? It will normalize the mean, right? The mean could decrease. Yeah, you want to come back to that then? Number 5?
Yeah. So number 6, Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So you would just do 150 160 minus 150.8 divided by 8.8. And I got 1.045.
Okay.
Is that what you guys got?
I'm gonna
Yeah, you see?
now. Divided by 8.
You see here?
Yeah. Can you hear me?
Yeah, I hear you. In this screen?
We went to 6.
Yeah, number 5 says you're going 6?
We're gonna come back to 5.
Yeah, okay.
Yeah, we're gonna come back to 5. Sorry, I got 1.045. Is that what you said you got?
1.045, yep.
Yeah, for number 6.
1.045.
Okay.
So then we use the applet for the number 7. What is the probability that a randomly selected student will score above 160? So if we put 1.045.
Give me a minute. Give me a minute. Because here I was lost.
Is that right? Because I have 0.148.
Yep, that's what I got.
Is that what you have, Mariella?
I'm trying to get the right number. Yeah, give me a minute, please.
Okay.
I lost my screen from the applet.
Do we have to figure out the z-score for number 8 for each one of those? 1, 2, 3, 4.
Yeah.
No. For the question, it's asking what's the sample mean of these students' score? What is it? So you find the mean.
Sorry, girls. Number 7, you got the area, yes?
Yes.
The area is 8749.
86, just to the right. It says the students will score above 160.
160.
So, because Diane scored 160.
Above, no? But I got 12.
12.
Your CETA score is 1.15?
1.045.
Well, I got different. Sorry.
So 160 minus 150.8 divided by 8.8.
8.8, no?
Yeah.
I was putting just 8.
Oh,
Yeah, that was the error. 0.45. Yeah, I got 14. I got 0.148.
yes.
Yeah?
Yes. That's for number 7, right?
Yeah.
And then number 8, what does Z-score sample mean of these student scores? So the mean on this one was 130, right? Brianna, is that what you got?
For what?
For number 8,
You got what?
130 was the mean. Minus,
I got the mean as 160.
okay, let me add that again.
All 5 is 800 divided by 5.
Oh, I got it wrong. Let me see. I have 150. 149 plus 153. You're right. Darn it. 160 was right.
160. Yes.
Yeah, 160.
But
minus-
that question's asking what the z-score corresponding to it is.
Oh, okay.
yeah, so we have to do the sample mean, right? I mean the z-score. So 160 minus 150.8 divided by 8.8, right?
Is that in the same? Oh, okay. Yeah, you're right. I don't
160
know what I was doing. I was trying to
divided.
put the standard deviation again, but I forgot they were all related questions. So, yeah.
So it's the same 1.045.
Oh, it is. Yes, it is.
That's cool.
I don't understand the number 8 because why does it score corresponding the sample mean of the student score? Ah, okay. Yeah. I got. Yeah, I got it.
Okay.
Number 9.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So we take our
With the
5 random.
probability, I don't know where you go there. Or do you?
I think you use the applet for that. 5
Right.
randomly selected students will
We
have a mean score.
Or do you plug it into the longer equation with 5 in the square root?
Yeah, you're right, because 5 is now our number. So so we would
Yeah,
say
it's the new
yeah.
the new n.
So we'd still take 160 minus 150.8 over standard deviation 8.8 divided by the square root of 5, right?
Yeah.
You're like, sure, sounds good.
I don't know. I don't know if we're doing the right thing or this is totally wrong. Or...
I know. Well, let's do it. Let's see what we get. 160 minus 150.8. 9.2
Square.
divided by 8 divided by 5 square root of 5 equals.
I got 2.337.
2.236 is the square 5.
In the square thing, I got 2.236. But then I plugged that into my equation.
You have you had 2.337 or 2.338?
Yeah.
Okay. And then you
But then would you plug that into the applet? Because it's like the probability. I don't know.
Let's see, probably 5 random students are having this problem. Yeah, it seems like
Please, could you share me your screen? Because we are doing the formula with the square, yes?
yeah.
But what is the score you are taking?
So if we're taking 5 randomly selected students, which is a number
Yeah.
sample, we'll have a mean. What is the probability that they have a mean score that is greater than the mean achieved by the students in the previous problem? Oh, you know what? I think we have to solve for x. So, because we don't really know what their mean is, right?
Yeah, we need to know the mean. Yes?
Yeah. So we gotta solve for x, but then what is the standard deviation? So we would say the standard deviation, because what is the probability? Oh, but we need the probability. Okay. I'm getting crazy here. I have a mean score that is great. Well, no, maybe not solve for x. Maybe it is the 2.338.
And then you put that in the applet.
And then you
And then I got 0097, and that sounds really wrong, but I don't know.
Have a mean score greater than the mean. Yeah, that's what I have.
I don't get anything, because the thing we need to discover is the mean. Yes.
The thing
But
that
we have,
no, we have to discover the probability that they're going to have a mean score greater.
We know the mean's going to be 160 because of the previous problem. We just want to know the probability that 5 random students are going to get higher than that.
Yeah, that's what I got too. Is the 0.0097. But
how is your formula working?
So
could I see? Could I see?
Yeah, let's see. Can I just show you my paper?
Yes,
Let me get to the screen so I'm sure. So, can I see that? You see the 160 minus 150.8, and then the standard deviation divided by the square root of 5.
And why you put 150?
150.8 is the let me go back to that problem.
The mean. The mean, yes.
Yeah, it's the current.
Yeah.
It's the no, it's 150.8 was taken from
the mean.
The very beginning. Yeah,
the mean
of everybody, normally distributed with the mean of that. Yeah, I got the same thing Brianne has, but then when we round it up to the third, it's going to be 0.01, right?
Yeah, but you're supposed to leave it as 4 decimal places.
0.010.
So 0.0097.
Oh, we're supposed to leave it at 4? Is that what it's? Yeah. Sorry. Thank you for reading that stuff. 0.0097.
And I don't know if that's right or not, but
No. Seems okay.
Okay. Let me do it again, please.
Okay, go ahead.
To solve this one.
I ran out of scratch paper. Shoots. I have to do everything wrong.
And I got 0.0097.
2 thumbs up. That's what we have.
Yeah?
Yes.
Okay.
All right. Well, number 10.
Number 10.
Suppose the
Okay.
mean GPA of BYU Idaho students is 3.5 and the standard deviation. Okay, so that's just telling a random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable which represents the sample mean of the 81 students who are selected?
Approximately normal. Because
Yeah.
the large,
It's over 30?
yeah.
Yes.
Okay. Okay.
What is the meaning of the distribution of the sample? Means
That's going to be 3.5, right? Or what is it? It's, yeah, 3.5.
That's all we have to do is put 3.5 in?
That's the mean.
the mean.
I
The
mean,
mean.
that
Yeah.
seems so easy. Like we don't have to do any math for it.
Not yet. Don't get too comfortable, Brianna. Yeah, we take it when we can.
What is the standard deviation of the distribution of sample mean? 81.
Standard deviation is
Is that easy again?
yeah 0.7.
Yeah. 0.7.
Okay. Well,
Okay.
I don't. It says round to 3 decimal places. So are we missing something?
No, because that is the standard deviation. Let's see. Supposed GPA 3.5. Standard deviation is 0.7. Left skewed. That's a standard deviation we would use. What is the probability? See, here we go. Here's the math. That the mean GPA for 81 randomly selected BYU students will be less than 3.3. So this is where we do our math, right?
Tengo trabajo de grupo.
Less than 3.3, so we use 3.3 as a.
My Excel doesn't work as fast as I want. 3.3 less 3.
Would you do the equation with divided by square root of 81?
81, yes.
Yeah, so 9.
Yeah, 81 is 9. 9 between the standard deviation, it's 0.7 under 9. And then I got what? $2.571.
That's what I got.
Wait,
Less,
say that
less.
again.
2.571.
You did the equation, the mean divided by the standard deviation square root of the number,
Yeah, the square, yeah.
and you got, so it's 3.5 divided by 7 divided by 81 square root of 81. Is that right?
Yeah. The square of 81.
Because 0.7 divided by 9 is 0.0777, right?
Yeah, yeah.
And then 3.5 divided by that.
3.5. It's not 2.0, 2.2, 0.2. Sorry.
0.2. Okay. Okay. Shoots. Let me see. Can you show me yours again?
Wait a minute, please. Screen share. You see the screen? No. Screen.
Not yet.
Screen.
Okay, I see it.
I'll show my Excel there. Yeah. The mean is 3.5, yes?
Uh-huh.
And the new mean is 3.3.
Where did the 3.3 come from?
And the question.
The question.
It did. Am I so blind here? Hold on.
The question says that.
Oh, yeah, I'm blind.
Yeah, 3.3.
Okay. 3.3, that makes sense because I was kind of going crazy here. Okay. 3 minus 3.5, right?
Yeah.
Divided by 9. And you get negative 0.0222, right?
Uh-huh. Yes.
2, 2. And then in your applet, plug that baby in.
But the probabilities all this area 90-90, Brianna.
Yeah, I didn't know which one it would be.
Wait a minute. But you have your, where did the 2.5 come from again?
2.5.
Wait, let me
Yeah.
see.
That was the answer.
It's the number 2,
Okay.
0.2
Uh-huh.
between 0.07777. You see?
0.0777.
Yeah, that was
Where did your 0.077 come from?
the standard deviation, 0.7 divided by the square root of 81.
Oh, shucks. Yes. I'm sorry. You're right. I missed that step. Okay. And 2.57, right? Okay. You put in 2.57 and you get 99.49. 0.9949.
So less than would be that whole area, the 0.9949.
Less than would actually be to the left of it, right?
I don't
The
know.
question here
On
probably.
the left, I think, no? On the left.
Yes, on the left.
The whole to the left of 2.570 or just to the whole left?
I think the whole left.
I think it's just
Because the question says that
less
it's
than.
less than, no?
Yeah.
So it's
So
going
then that. So it'd be 0.51 and then greater than would be the 0.9949. Right?
0.995.
0.995 would be the equal to or less than, right? Then the greater than would be
Well,
just.
okay, so the mean is 3.5,
Uh-huh.
and that's 50% if we're thinking about it like that. And so less than 3.3 would be less than that. And if it's 0.9949, that wouldn't make sense to me. I don't know. I looked at, like without looking at the math we just did.
Yeah, I see what you're saying because 3.5 would be right in the middle.
Yeah, so that's at least 50%. And so being less than 3.3 cannot be 99% of the population. I don't know if I'm totally wrong on that.
90% of the population? Sorry.
Well, you got your answer as 0.9919 or whatever she got. That would
almost everybody got good, excellent grades.
Yeah, and I don't see that happening with less than 3.3. Because that's not that many people are going to get that low. But greater than 3.3 is going to be all the mean plus everyone who's higher.
Okay, so
your answer from that math was -2. I got -2.570, and so I guess it's just a rounding problem. So I don't know.
And then
they grade that. So even if we do that, then it's 0.0051 to the left.
Yeah, because that's what I got to the left. If you just click Mariela on just the left side
Mhm.
and take out the middle.
And then
Yeah.
and then for greater than 3.3, then it would be the middle plus the right.
Right.
Because that makes more sense that from there to all the way to 4.0, you're going to have a lot more.
Mhm. Yeah. So if you just, that's what I got to 0.0051 is the probability. So it's to the left of the yeah, that one, and then everything else is out. That's what I got. Is that what you got? That's what you're talking about, Brianna, right?
Yeah.
Yes. Yeah. You got. Yeah, it's 0.005 because we are doing the right and we are saying that it's greater than, no less than.
Well, for number 13, it would be 0.0051 because you're looking at less.
0.05. 0.05, just 3 decimals?
Oh, yes, you're right. You got me on that one. And then on the next one, it would be 0.995.
Yeah, it's greater than. Yes, you have question. You have reason. Yes. Last one. It says the United States Coast Guard assumes the mean way of this information.
Okay, so this one it's a long question, but the numbers are all the ones we need. So
Okay.
177.
15?
Yes. 6.7. Okay, so for the score, I got negative 1.92018.
So I'm just factoring that out. So our X would be 185, right? Minus the
Well, yeah, you would have 177.6 minus 185.
It's the other way around.
Yeah, because you're sample minus your regular mean.
Sorry, wait a minute, please. I am finishing the math operation.
And then are we taking the number is 48, the square root of 48?
Yeah.
Okay.
26 divided by this.
How much do you got for zeta score there?
For Z score, I got negative 1.92.
2011, no?
Yeah, I got 1.8, but it doesn't matter because it rounds up.
Okay, I'm almost done. Sorry.
1.92. The question is, find the probability that random sample will have a weight that is How to answer that question?
Or is 1.92? 2? Is that what you said, Brianne?
1.92.
Yeah, Z-score.
Yeah.
Okay.
Yeah.
Okay. The sample means you find the probability that the random sample passage will have a rate extreme or more extreme. Was that a negative 1.92?
Yeah.
Yeah, negative, yes.
92.22. Sorry.
So then either above or below, so 0.0549 or
Sorry?
So 0.0546 plus 0.0546, right?
would that be, well, if you select both, that would be adding the two sides.
Yeah, so it would be 0.1092. Wait, let me see.
Well-
Hold on. Find the probability that a random sample passage will have a weight as extreme or more extreme.
0.0549. I got that.
So it's going to be equal to or more than.
Well, the number is. Brenda, could you show your applet? It's not there.
Oh, I see what you're saying. You're saying 0.54.
9?
Oh, okay. I have 546, but it's about the same, right? On both sides. But is it
Yeah, both sides.
extreme? Is it less and more, or is it?
Yeah, so you'd select the left and right, right? Mhm.
Yeah, I was trying to see because it says find the probability of random sample passage will have a weight that is extreme or more extreme.
Well, I'm just gonna, I have to get to going to work, so I'm just gonna put point, I'll just put in that answer and see what I get on the quiz and see what you get, like.
Oh, don't forget number 5 though. We didn't answer that one.
Oh yeah, well, I'll see if you can take it again, right?
Yeah, I think
Yeah.
number 5 we were gonna just say
Law of larger.
I'm gonna put for number, the last one, I'm just gonna put 0.055 and see if that's right or wrong. And then for number 5, I'm just keeping with normal distribution to see. And again, you guys can, I'll tell you guys what I got and you guys can change your answers.
okay.
Okay.
I just really need to get going to work, so.
I know. I know.
Okay, so number 4 is wrong.
Number 4 is wrong.
And number 5 is wrong.
Number 5 is wrong. So number 5 is not normal distribution.
No.
I think that number 5 is the law of large numbers.
And number 8's wrong, and number 12's wrong.
Okay.
Oh, no.
Stop.
Those are, we got 4 wrong. So it's
but
right
you got
now we're a 76.
But you got the last one right, so it was the 0.5.
Yeah, it's 0.055.
0.055. Okay.
Yep.
Okay. And
The
so
last one is 0.055.
5. Yeah.
Okay.
So you
well,
said
I'm
number
just-
5, 8, and 12. 4, 5, 8, and 12. Those are
Yeah,
the
those
ones,
are the
right?
ones you need to go over again.
Okay.
But all right, I need to go.
I'll try to
Okay.
figure that out. Hey, Brown,
All
we'll
right.
see you.
I'll talk to you later. Bye.
Right.
Bye.
Number 4.
4. Let's go back to number 4.
Which of the following have a smaller standard deviation? Which of the following have a smaller standard? Ah. Yeah.
I think it's a second one. The distribution
The
is the
second,
sample
yeah.
mean. Yeah.
The 7 means, yes.
Yeah. So I think 4 is number 2. And then
the
number 5, which of
I
the
think
following?
it's law. I think it's law of large numbers.
Law of large numbers. Let me look back again. Large as the sample size and
Could you see the
increases
screen?
sample
I will
mean.
show my screen.
Okay,
My
okay,
sc-
show me your screen.
because there I read in lesson 5 about this. What's lesson 5? No? Sorry, many windows open.
I know, mine too.
Yeah, here is lesson 6. Here is a question. It says, if the standard deviation of a sample mean gets smaller, what happens with the value of the mean? The values that we will say will be very close to each other, therefore, close to you if the sample size is large.
Large. Okay, yeah. So then that's going to be the law of large numbers.
Round of numbers.
Okay, that's okay.
Number 8, she says, no?
Yeah, she said number 8 was wrong.
And number 12?
Mm-hmm.
Number 12, what is?
Oh, I thought number 8 was easy. Oh gosh.
What do we got wrong on number 8?
So
Yes, multiply again.
what is the probability that the round? Okay, let me look at this. Number 8. I have my scratch paper.
Yeah, the mean was
So the mean. So number 8 is the sample mean was 150.8, and the standard deviation. Oh, is it the sample mean? Yeah. Was 8.8. So number 8, what question was random sample 5 students whose their scores are.
Oh, we did something wrong there.
Was it the way we did there? Because a random sample. 16.
$2.33.
Let me see. Two divided by 5 equals 2.338. That's what we had. That's the z-score. Oh, so the z-score. So we plugged it in, but it should just be 2.338. Okay, because that's our z-score. I don't know why we plugged it in, because we were only trying to find the z-score. So yeah, that's what I have.
And why we put this number? I don't understand.
I think because we plugged it into the applet. Because if we went kind of far with this, we went 2.338. And then we got the, what was the
Something
number
wrong
we
with
had in there?
1.045.
Oh, wait a minute.
The first answer we have was 1.045.
Yeah, it should be 2.338.
2.331. I get 1. I don't know.
Say that again. Let me see.
That's because I'm using less numbers from the deviation of the square. Yeah. 2.338. Yes?
Yes. Yes.
Yeah.
That's what I have.
Okay. Okay. 338. Yes.
Mhm.
Okay. Number 12, she says, no?
Yes. So wait, let me see. Number 8.
What is standard deviation?
Wait, what was number? Okay, and then 12 is.
I think we have to do all the operation.
Oh, what is the standard deviation of the distribution sample means for all possible sample size could drawn from parent population? So I thought we said so. Our
But this is distributed left skew.
so okay, so all sample size is you drawn from the parent population. Round the answer to 3 assessment points. So our standard our equation to do this, find the standard deviation is because it's not a z-score. What lesson was this? I think the standard deviation of the sample mean is the standard deviation divided by the square root of the number. So standard deviation 0.0, it's 0.7 divided by the square root of
7777. Yes.
0.0778, right? 77. 0.0778. That what you have?
Yeah, are the same. Yeah. Submit now. Crossing fingers. Oh my gosh. Yeah.
100%?
Yeah, 100%.
Okay. So gotta let Brianna, I'll email Brianna and let her know because that's the thing is we didn't factor in the standard deviation for 12. 0.0778.
Yes, yes.
And then okay, well good job. We're all done with that. It's like, oh gosh, so long.
An hour and a half.
I'm gonna stop broadcasting.